Hello, today I will be going over the Solar Cars project competition for the MESA program. I will be letting you guys know what exactly this project looks like, what are some of the materials that are needed, as well as the competition and judging guidelines for the project. Okay, so what is this project? Students will design, construct, and operate a vehicle that runs on solar power. The end goal of the project is for students to build a car that crosses the entirety of the track in the fastest amount of time possible, as well as building a solar car with the given specifications. Some of the learning objectives are for students to be able to understand the engineering design process and use it to build a successful vehicle, introduction to mechanical engineering, team building, develop planning skills, further develop critical thinking and analysis skills, and understanding elements of physics and engineering involved in the project, as well as further developing their presentation skills and being able to speak on what they created. Okay, so here is the engineering design process that we want students to refer to. The goal of just about any MESA project is to learn the engineering design process. First, you must identify the problem. After determining the problem and brainstorming ways to solve it, you explore and find out what others have done and start to tinker with materials. Next, you design your solution. Map it out using drawing and or models, however the students prefer. From here, you create your idea. You make your solution come to life. Implement the design you made to build your solution. Next, try it out. Test your solution and notate the outcomes. And then finally, after testing, review your notes and brainstorm how you can improve your design. Modify it, rebuild, and retest. Continually improve until you reach the outcome desirable to you. So here are some of the materials needed. Um, Materials may be requested from MESA, which includes but are not limited to solar panels, propellers, tape, motor, wires, and wire cutters. All materials are legal with the exception of hazardous materials. And there are zero cost limitations, but awards will be given to the most innovative designs that use low cost materials. In addition, the host center will provide a 20-meter track with access to sunlight. And then, if we are unable to do it outdoors, the MESA program will offer battery packs with wiring as a substitute. Okay. So here are some of the guidelines. There will be 2 to 5 students per team. Students will design and create a vehicle that runs on only solar power. Solar power must be the only power source for the vehicle, and they are limited to the maximum output of 3.2 watts. There is only one motor allowed per car. And in addition, the vehicle must also have a passenger seat to replicate everyday transportation. You don't have to include a model passenger, but if students want to, that is always an option. The solar panel cannot be the main part of the vehicle, and the axles and the wheels cannot be directly attached to the solar panel. So the vehicle must be intact without the solar panel. If the sun's energy is insufficient for judging, a battery pack with 2 AA 1.5 volt batteries will be used during judging. And then another specification is that solar cars must not exceed the 30 by 60 by 30 centimeter size rule. The vehicle must also be labeled with the students' names, grade, school, and MESA Center. And if this is not done properly, they will receive a 5% point deduction. Okay, so here's a competition for high school. The track itself will be 20 meters by 2 meters long. The goal is to cross the entirety of the track in the least amount of time possible. Vehicles will be given 2 non-consecutive runs. And then after their first run, repairs can be made in the official repair area, and they must be ready when the team is called. And then, in addition, repairs may only use replacement parts and materials. No new materials can be introduced at this point. Once they're back on the track, the vehicle must be in ready, hands-off position with front wheels within the start zone. One team member is responsible for the launch and must wait until the judge signals. Time begins when the judge calls start and ends when the front wheels cross the finish line. And then the team member cannot touch the car once the lever is tripped. In addition, high school students will need to submit calculations to show that they've used equations to determine how distance factors into car travel. Okay, so here are the high school requirements. High school teams must use a theoretical calculation of the amount of time it will take their solar car to travel 20 meters using the following equations. So below we've included some of the formulas that the students can use. Oh, and let me see. The calculations should be presented together with the solar car. So students must bring these with them on the actual day of the competition. Okay, so the competition for middle school is very similar to high school. The track will be 20 meters long by 60 centimeters wide. The goal of each team is to cross the entirety of the track in the least amount of time possible. Vehicles will also be allowed 2 non-consecutive runs, and the best time will be kept. So in case the car doesn't cross the entirety of the track, distance will also be recorded just in case. Vehicle must be powered on after the judge says start, and the vehicle must move forward without the student's help. Completion. Students' vehicles must meet all the vehicle specifications, and then if the specifications are not met, there will be a 5% point deduction. So here are some of the examples that students can refer to when trying to build their own solar car. Okay, so now this part is for judging. So vehicles will be checked for specifications prior to the start of the competition. If the devices are disqualified, the student's first trial will be forfeited, but they may try to bring up the vehicle up to specifications by the second trial. So the things like only having one motor, making sure that there's a passenger seat, having the calculations for high school, and making sure that it meets the measurement requirements are all like some of the things that will be factored in these specification checks. So once the specification checks are completed, we now move on to the speed trials. So one student will place their solar vehicle behind the start line as designated by the yellow tape. Judge 1 will ask the team member to set their vehicle in ready position. During this time, the team member will cover the solar panel to prevent a false start. Only one false start will be allowed, and the team will have to forfeit that trial. Judge 2 will start the stopwatch when Judge 1 says start. Judge 2 will stop the stopwatch as soon as the solar vehicle's front wheels have crossed the entirety of the finish line. So if the finish line is not crossed, the judges will measure the distance from the start to where the front of the wheels of the vehicle stopped. This will be recorded on the rubric, and the lowest numbers will be the top scores in terms of time. So practicing with sponge activities. In case students have gone are interested with their Solar Cars project, they can also check out the Air Powered Vehicle Challenge. This is a good activity to help students understand the concept of vehicle design. And students will create a vehicle using sails, using provided materials, and then the goal is also to travel the greatest distance when placed in front of a 9 to 10 inch stationary fan. Thank you for your time.